from section 1.6. And I will post that in the due date after class, along with the email that I usually send to you after class. And the exam, I will work on grading it today. Hopefully get that to you later today. Okay? All right. So section 1.6 is on solving other types of equations. So far we've looked at linear equations and we've looked at quadratic equations, and that's more or less it. But there's all kinds of variations on those, that you can solve. So let's start with polynomial equations. All right, so again, please remember what an equation is. An equation looks like this. You have a left expression, and that's equal to the right expression. There's a left expression, right expression, and they're equal. That's an equation. Okay, so a polynomial equation. So, for example, right, x to the fourth minus x to the third minus 6x squared is a polynomial. X squared minus x to the third minus 6, or x to the fourth, equals 0 is a polynomial equation because it's a polynomial. It's an equation in which left and right hand expressions are both polynomials. So this is a polynomial. 0, you could think of that as a polynomial as well. If you have a polynomial on both sides, of course, you can push the whole thing over to the left. So polynomial equations if you can factor the polynomial when it's equal to 0 on the right, you can always solve. So if the polynomial can be factored, into linear factors, then the equation can be solved when it's equal to 0. So, for example, we're taking techniques that we learned about how to manipulate polynomial expressions in previous sections, and now we're applying them to these equations. Just how math goes. You build by little steps until you get to something, significant. So x to the fourth minus x to the third minus 6x squared equals 0. This can be factored. Of course, we've got a common factor of x squared. The lowest power of x, that's a common factor in each term, is x squared. Highest power. The lowest power of x in each of these three terms is x squared. So you can factor out that lowest power. So x squared, which leaves you with x squared minus x minus 6 equals 0. And this can be factored now as x minus 3, x plus 2 equals 0. Okay? So now we've got a product equal to 0. Okay, so a point to remember. Right, A times B times C equals 0 implies, right, A is 0 or B is 0 or C is 0. Not just with two, you know, two factors or three factors or more, for any number of factors, right? A times B times C times D equals 0 implies A equals 0, B equals 0, C equals 0, or D equals 0. Okay, so that's what we have here. Right, so you'll have x squared equals 0, or x minus 3 equals 0, or x plus 2 equals 0. X squared equals 0. Well, you know, that only happens when x is 0, of course. Right? Or this one, just add 3 to each side, get x equal to 3. Or this one, you subtract 2 from each side to get x equals negative 2. And so this polynomial equation of degree 4, set equal to 0, has 3 solutions. It has up to 4. 0 is, in a sense, a repeated solution because you have 2 factors of x. So 0 is a... You can think of it as up to 4 solutions or exactly 4 solutions with 0 having multiplicity 2 or something like that. That's something you'll talk about in other courses. Not that, you know, these are the only polynomials that we are able to factor completely into linear factors when you just have these common factors of x. Remember, there was also this grouping technique. There's more than the grouping technique for doing like degree 3 and higher polynomials. So this polynomial, this grouping technique, it only works for degree 3, by the way. By the way, so far in your mathematical education, maybe I'm not exactly sure, of course, but in this class anyway, you've only got 2 techniques for factoring polynomials of degree 3 and higher. There's this kind of factor, this kind of technique where you have a common factor of x, and that's just factored out, and then you're left with the degree 2, and then you factor, and then there's this grouping thing, and that's it. Okay, that's all we've got so far. In your 135.0, I believe they'll start talking to you a little bit about long division of polynomials and, you know, what the possible roots, solutions to polynomial equations are. So there's a little something extra that you can learn, but it actually doesn't go too far. Essentially, hardly any polynomials factor. So anyway, this grouping technique, this is about as rare as it gets. But let's do it. It's worth talking about. So let us group terms together. Okay, these 2 terms and these 2 terms. So notice this is a minus. First of all, I'm going to factor out this minus. Well, let's not do it that way. So group the first 2 terms together and the last 2 terms together. So the first 2 terms have a common factor of x squared, right? So let's pull that x squared out, and what I'm left with is 2x plus 1. Right? The second and third factor have a common factor of what? Since they're both negative also. But what's a common factor in both?
Negative 9.
Negative 9. And you're left with 2x plus 1 again. And this is the, you know, why the grouping technique works in these rare cases is that you left with this common factor, and so we took the 4 terms and turned them into 2 terms. Right? This was 4 terms, 1, 2, 3, 4. We grouped them 2 and 2, and now we got 2 terms, right, that we're subtracting. And they have a common factor of 2x plus 1. And that's when that grouping thing works. Of course, there's absolutely no reason why. You can always do this grouping and factor out, but there's absolutely no reason why you're going to come out with this common linear factor. Okay, so 2x plus 1, and then you're left with x squared minus 9. And the bit that's left over, it will be a difference of 2 perfect squares. Well, not that the 9 doesn't have to be a perfect square, but that doesn't matter because you can always just use square roots. But in this case it is. So this becomes 2x plus 1. And then this one is x minus 3, x plus 3 equals 0. So you have 3 factors equal to 0. So 2x plus 1 equals 0, x minus 3 equals 0, or x plus 3 equals 0. This one gives you x. So just solve this one real quick. I mean, we've done these enough. What's the solution here? Just look at it and say it. What is it?
Negative half.
Negative 1/2. Good. So, you can go through the details of solving it if you want, but if you just see the answer is negative 1/2, you can just write that too. Whatever you're comfortable with. Whatever you're comfortable with. If you can skip steps and come out with the right answer and be confident that you get the right answer, by all means do so. Don't do more scratch work than you need to. This one give you x equal to 3. This one give you x equal to minus 3. All right, so grouping comes up every so often. All right. So those are polynomial equations. So we've also learned how to deal with rational expressions. And the essence of this type of equations with rational expressions, is you want to reduce it to a polynomial equation. Okay, so the main idea is to reduce to a polynomial equation that you can solve using a least common denominator or simplifying nested fractions. Nested fractions or compound fractions or whatnot. So, for example, so now, again, we've already looked at this type of thing, but and the previous time we looked at it was only when it boiled down to a linear equation. So in these examples here, there'll be more, complicated things, quadratics, cubics, whatever. Okay, so look at this equation. Okay, we got these 3 rational expressions. Factor first, so factor the denominators. You would do that in order to figure out what that least common denominator is going to be. And the least common denominator is going to be the polynomial that is the smallest degree polynomial that is the product of all those factors. Well, that contains all those factors. Okay, so among these rational expressions, we got factors in the denominator of x plus 3, x minus 3, and x plus 3, x minus 3 over here as well. So that's all there is, x plus 3 and x minus 3, right? So the least common denominator will be x plus 3, x minus 3. So what you're going to do is multiply both sides of this equation by that least common denominator. Now, when you do it over a sum, make sure you put parentheses around the sum, like that, right? So there's the sum or difference on the right. So when you multiply the whole expression by whatever, something, or divide the whole expression by something, make sure you put parentheses around it. Okay, so let's clean up this expression and then do some cancellations, and then all the denominators should go away, and we're left with a polynomial equation. So here we got x times x plus 3, x minus 3 over x plus 3. Here, 2, oops, how did that become a 2? X plus 3, x minus 3 over x plus 3, x minus 3. Minus x plus 3, x minus 3 over x plus 3, x minus 3. All right, I take this and multiply, and I distributed it over this subtraction. So x plus 3, x minus 3 times this, x plus 3, x minus 3 times that. Okay, so now let's do the cancellations that we have. Right? And here, there was just an x minus 3 on the bottom. Sorry. X minus 3. Here we've got this cancellation. Right? And notice that the entire bottom of the fraction can be thought of as one factor, x minus 3. So I'm canceling out that whole factor on the bottom. Right? I have 3 factors on the top. 2, x plus 3, x minus 3, and 1 factor on the bottom, x minus 3. I mean, that factor has subtraction within it, but the last operation on the top, remember what factored mean, the last operation on the top in the evaluation of this expression is the multiplication. Addition and subtraction come first. Here, everything cancels out, top and bottom. So we've canceled out all the denominators, right? Just leaving 1. When you cancel out all the factors in the denominator, it leaves a 1. But you don't write fraction over 1. You just get rid of it. That's the whole point. And this one's just 1. 1 on the top, 1 on the bottom. Right? All the denominators are gone. Gone, and we're left with a polynomial equation. Right, so with the polynomial equation, you want to push everything to the left and put a 0 on the right. So multiply it out. So here we got x squared minus 3x, 2x plus 6 minus 1, x squared minus 3x equals 2x plus 5. Subtract 2x and 5 from both sides. So I have x squared minus 5x minus 5 equals 0. So I was not expecting that this would not factor. Let me make sure I didn't make an error anywhere. X minus 3 minus 2x plus 5 x plus 3, that's just 1, x times x minus 3. Yeah, that's fine. Okay. Well, so this left us with a quadratic equation, right? We have this whole thing is just a polynomial equation. Oops, a polynomial equation, and with the polynomial equation, all right, what you want to do is push the whole polynomial over to the left and get a 0 on the right, and then use whatever techniques we have. With this one, well, it doesn't factor. I was certainly expecting that it would. So I guess we have to complete the square. So take the 5, divide by 2, and square it. So that's 25 over 4. 25 over 4 equals 5 plus 25 over 4. So this one is x minus 5/2 squared. And then this is 20 over 4 plus 25. So 45 over 4. Square root on both sides. X minus 5/2 equals root 45, which is over root 4, which is 2. Then get rid of the absolute values. Plus or minus. Square root 45, so that's 9. 9 times 5. So that's going to be 3 square root 5. Square root 9 times square root 5, which is 3 root 5. So x is equal to, and then you add that 5/2. 5/2 plus or minus 3 root 5 over 2. So you have two solutions. X equals 5 plus 3 root 5 over 2, and x equals 5 minus 3 root 5 over 2. Or whatever. And or. Alright. So, I mean, hopefully it would come down to factoring and solving by factoring, but this problem didn't. Okay, let's try another one of those. It's definitely something worth looking at another example. Let me see what we got here. How about this one? 10 over x minus 12 over x minus 3 equals negative 4. Okay, so we've got these rational expressions. What would be a common denominator? What are the factors you see in the denominators of these things? What do we have? What factors do we have in the denominators of these rational functions?
X into x minus 3.
Yeah, x and x minus 3, right? These linear factors. So a least common denominator. Least common denominator is just going to be, the product of, these factors that contains, all of them. The smallest product of these factors, smallest degree. So just x and x minus 3 will do the job. So you want to multiply both sides of this equation by x times x minus 3. Okay, so x times x minus 3 times 10 over x minus 12 over x minus 3 equals minus 4 times x minus 3. All right, so let's multiply this through. 10x minus 3 over x minus 12 over 12x minus 3 over x minus 3 equals, well, this one there's no fraction to deal with there, and that's fine. All right, so that's what we've got so far. Now cancel out those common factors that you've got in each one of these. Here the x's go away, here the x minus 3. Lo and behold, we've emptied out all the denominators in the rational functions. So we're just left with polynomial equation. So you got 10x minus 3 minus 12x equals minus 4x minus 3. Okay? So now we've got a polynomial equation. Okay? Multiply it through, push everything over to the left. To the left. Or right, if you like the right. Okay? So this is 10x minus 30 minus 12x equals, so this is minus 4x squared plus 12x. Okay, push everything over to the right. So I'm going to add 4x squared, subtract 12x. Add 4x squared, subtract 12x. Common mistake. Notice there's a minus 12x here already. So there's plus 12x and here's a minus 12x. To move this plus 12x over here, I'm going to subtract 12x from both sides. That doesn't cancel out this 12 minus 12x. It doubles it, right? So, you know, kind of that sign mix-up sometimes gets people. Like, I mean, now you got x minus 10 equals 10 or something like that. And you got to subtract 10 from each side. And you get x minus 20 equals 0. Or I should have added 10 to each side or something like that. And you have x equals 20. Sometimes I'll see people do something like this and they'll tell me x equals 0. No. That would be the case if you had a plus here, because you have plus 10 and plus 10. So when you see these matching numbers, don't just cancel them out right away. Check the signs. Either you cancel it out or you double it. Okay, common mistake. Common mistake. I will tell you common mistakes, you know, as we go along and give you a little forewarning. You know, that's the benefit of experience on my part. All right, so what do we got here? So 10x minus 30. Let's put the 4x squared over here. 4x squared plus 10x minus 30 minus 24x equals 0. Now collect all these terms. You got 4x squared plus 10 minus 24. So that's minus 12x minus 30 is 0. Now, with this type of polynomial equation, we can divide both sides by 4, right? Because you've got 0 over here.
Is it 12x or 14x?
14x.
Because it's negative 24
Indeed,
plus...
right, yes. Good. Good. I'll just make sure I didn't. So 10x minus 12x is minus 2x. Yeah, 14. So, well, divide by 2. This is a common factor at 2 here, so this might make life easier. Equals 0. By the way, you can't do that when it's not an equation. Right? If you had just a polynomial expression, you can't just randomly divide it by 2. Right? With an equation, you could divide both sides by 2 and things stay equal. Another common mistake. Anyway, this one, let's see. Does it factor? Better. So 15 is 3 and 5. I think that 3 and 5 is going to do it. Minus 10 plus 3, or minus 5 plus 3. So that's minus 10x plus 3x gives you minus 7x. Good. So 2x plus 3 equals 0, or x minus 5 equals 0. This one gives you x equals negative 3 halves. This one gives you x equal to 5. A lot of steps there, yeah? A lot of steps. Do you remember what I told you about writing the math correctly? In ways that, in ways that make sense. This is starting to become important. As problems have multiple parts to them, writing your equations and evaluating your expressions in a way that is organized and correct is important so that you don't get lost within the calculation. All right. Again, proper writing of the mathematics is a reflection of proper understanding. Proper understanding is reflected in proper writing. It's just the case. And that's not just in mathematics. It's with anything. When you write in about whatever it might be, clear thinking is reflected in clear writing. And no matter what the topic is, math or anything else. Okay, so let's look again at what we've done here. So in this, that's probably too small for you to even see. So in this expression here, first we found the least common denominator, x times x minus 3. Multiplied both sides by x times x minus 3. If it's got multiple terms, don't forget the parentheses. Multiply through, cancel out those common factors, and boom, you're left with a polynomial equation. And now what you want to do is multiply it through and push all the terms over to the left. So, we multiply this through and blah, blah, blah. Lo and behold, we're left with this polynomial equation. 4x squared minus 14x minus 30 equals 0. You need that equal to 0. Essentially because you'd like to factor and cancel. So in order to factor and cancel, you need a 0 on the right. So here we had a common factor of 2 on the left here, so we've divided out by 2 on both sides. 0 divided by 2 is still 0. And then this guy factors. Right? And there's the solutions. All right? Let's take a nested fraction expression. Or a nested fraction example. So 3 plus 1 over x over 2 minus 4 over x equals x. Okay, so step 1 would be to simplify the nested fraction expression into just one rational function, into a simple fraction. All right, so first simplify the nested fraction into one rational function. Right, so again, you want to use this a over b over c over d thing is equal to a over b times the reciprocal of the bottom, d over c. You want to do that thing, but we don't have a fraction on the left. We have on the top and the bottom. We've got you know, sums of rational things. So you have to evaluate that sum first before we can get just a simple fraction on the top. So make a fraction on the top and a fraction on the bottom so that we can apply this. Okay, the common denominator for these two fractions on the top is going to be x. So the 3 becomes 3x over x plus 1 over x. On the bottom here, right, common denominator is x. So the 2 becomes 2x over x minus 4 over x. Whole shebang there equal to x. When you're solving an equation, okay, you, at each step, write the entire equation, right? And you stack those equations with, you know, the equal signs lined up as much as possible. It's not always possible, but, you know, that's the way to do it. So when you're solving an equation, you stack your equations. When you're evaluating expressions, which we had done for most of Chapter P, when you're evaluating expressions, which we did for most of Chapter P, you use a chain of equalities from left to right. All right, so again, proper notation. So here we're stacking, right? Here these previous examples we're stacking an equation. We got an equation, then we write another equation, then we write another equation, where at each point the expression on the left is manipulated. So this expression equals that expression. Right, so there's chains of equalities going down the left and down the right. So this is equal to this. This is equal to that. But the two sides themselves are equal. So, you know, we have to so we have to maintain that. That's the main equality that we're looking at, is the one in the middle here. All right. Adding together 3x plus 1 over x over 2x minus 4 over x equals x. Now I have a fraction on the top and a fraction on the bottom. 3x plus 1 over x. X over 2x minus 4 equals x. Multiply together, cancel common factors. So I got 3x plus 1 times x over 2x minus 4 times x equals x. Don't leave out the rest of the equation. All right, I mean, if you kind of, I mean, since we're only manipulating the left and not the right, if you want to just kind of leave it out like this, that's okay, you know. But better to write the whole thing each time. Again, guys, please speak and don't use the chat. See, now I have to go here and then go like this. Okay, that's probably a mistake. So we have a common factor of x here. So we got 3x plus 1 over 2x minus 4 equals x. Multiply both sides by 2x minus 4. Right, I do that to cancel out this one on the left here. Guys, can we use the chat? Just speak, please. Oh, that's right. So we want to cancel out the 2x minus 4, right? So now at this point, at this point, we're left with one of those previous types of equations: a rational expression on the left and a rational function on the left, rational function on the right. So we multiply by a least common denominator, or, you know, sometimes folks like this idea of, if you have a fraction over a fraction, you can use cross multiplication. It's the same thing, but let's write it out. So here's an algebraic trick. Cross multiplication. All right, given A over B is equal to C over D. So if this, then A times D is equal to B times C. So that's an algebraic trick you can use. That's when you have a fraction equal to a fraction. Or you can do that least common denominator thing. The least common denominator is going to be B times D. You know, whatever you like here. So if you want to do the cross multiplication, you don't have a fraction on the right here, but you can make it 1 by just putting x over 1. So now I got 3x plus 1 is equal to x times 2x minus 4. Now we're down to a polynomial equation, right? A lot of steps here. 2x squared minus 4x. Push all those terms. I'm going to push them to the right this time. Why? Because I want the leading term to be positive. 2x squared minus 7x minus 1. This one does not factor. Yeah. This one doesn't factor. So you're going to have to complete the square, unfortunately. So let's do that. So I'm going to switch the equation around. Divide both sides by 2. So I got x squared minus 7 halves x equals a half. 7 halves divided by 2 is 7 fourths. 7 fourths squared is 49 over 16. And 7 halves divided by 2 is 7 fourths. Multiply the bottom of the fraction by 2. 7 fourths, and then square that, you get 49 over 16. So this here is x minus that b coefficient divided by 2 squared. And this is 8 plus 49 is 57 over 16. How nasty. Take your square roots. Alright, so you got x minus 7 fourths is equal to, so 57 I believe is a prime number, isn't it? Yeah. 56 is 7 times 8. 57 I don't think is maybe divisible by 7. No, 7, of course not. 7 times 56 is multiple of 7. Oh, 9 divided by 3? Yeah, it is, isn't it? How about that? But it doesn't help. It's 3 times, 19 times 3. How about that? Yeah, but that doesn't help. It's 19 is a prime number, as is 3. So anyway, that doesn't. It's just square root 57. So x minus 7 fourths is plus or minus root 57 over 4. So x is equal to 7 plus or minus root 57 over 4. And so x is 7 plus. About as ugly a solution as you can get. Alright, well, anyway, it's just a number, but it's just not a rational number, integer, or a nice fraction of any sort. Alright, so I would definitely try to make problems that don't end up being reducing to nasty polynomials like that. But, so what did we do in this one? Let's go over it again. We started with this here. Okay. First thing we want to do is apply this. right? A over B over C over D is equal to A over B times B over C, or D over C. All right, so, but we can't do that because we don't have a fraction over a fraction. This is multiple fractions all nested together. So we have to add these rational functions on the top and add these rational functions on the bottom into one rational function in order to do that. So the 3 becomes 3x over x plus 1 over x. The 2 becomes 2x over x minus 4 over x. Give me a common denominator on top and bottom, so I have 3x plus 1 over x over 2x minus 4 over x equals x on the right. Now we do this fraction on the top times the reciprocal of the fraction on the bottom. Right? We got fraction over fraction, so we can do this simplification. All right, so now cancel any common factors on the top and bottom of this thing here. We cancel out those x's and we're left with this. 3x plus 1 over 2x minus 4 equals x. Multiply both sides by a common denominator. But, a shortcut to that is this, this special case of cross multiplication. If A over B is C over D, then A times D, this diagonal, A times D is equal to B times C. It's cross multiplication, it's only when you're solving equations. Okay, so to solve this equation, A over B equals C over D, use AD as BC. So here we got 3x plus 1 times 1 equals 2x minus 4 times x. So that's a polynomial equation. Push everything to the right. Hopefully it would factor and cancel. It doesn't, so I've got to do this completing the square thing, and there's the answer. A lot of steps. Okay? Got to stick with it. Got to look what you have at every step and, be clear on what it is that you're supposed to be doing at each step. It goes without saying that if you have not mastered the material before, at this point, this is going to be hard. Right? If you didn't master the rational function simplification stuff, then, this is going to be difficult. If you didn't master factor and solving by factoring, if you didn't master factoring, you're not going to be able to do solving by factoring. Okay, this is a culmination of everything we've done so far. All right, so, if you've had trouble with the stuff from before, now this is going to be difficult, this section. But it's not too late. You can get caught up. I'm here to help. All right, if you want to meet, just let me know. What else? Equations with square roots in them. If you have something like this, given square root A is equal to B or something like that, all right, we can square both sides. All right, so square root A squared equals B squared. But square root A squared is just A, is B squared. And then maybe you can solve. Right, so you eliminate the square root on the left by doing that. So, for example, suppose we have 4 minus 6x, excuse me, minus 2x equals 0. I don't have this yet. Square root A is equal to B. But what I could do is add 2x to each side. And now I'm going to have 4 minus 6x equals 2x. Now I can square both sides. So this becomes square root 4 minus 6x, the whole thing squared, equals 2x, the whole thing squared. So this on the left just is 4 minus 6x. And this on the right is 4x squared. Push everything to the left or right. So 4x squared plus 6x minus 4. Divide both sides by 2 here. So 0 is 2x squared plus 3x minus 2. This one will factor. So minus plus 2 minus 1. Right, so this is plus 4x minus x. Right, plus 4x minus x. So plus 4, so the outside times the inside terms in this 2 by 2, multiplication problem here. Plus 4x minus x gives me the minus 3x, right? And of course, 2x times x is 2x squared, and minus 1 times 2 is minus 2. So 2x minus 1 is 0, or x plus 2 equals 0. This one gives me x equals positive a half, and this one gives me x equals minus 2. Okay, that's if you've got square root on the left equals something on the right, which might be a square root as well. By the way, you cannot square it right off the bat. Well, you could, but it's not it won't help. Okay, watch out for this mistake. So square root 4 minus 6x minus 2x equals 0. So on the left, I don't have just square root something. It's not just a square root. It's a square root of something minus 2x. So suppose I was going to square both sides now. What's the problem here? Do I get rid of the square roots? No. What's this squared? Well, you have to square it. Guys, nothing distributes over addition. Squares, square roots, nothing distributes over addition. Yeah, I forgot that one. This is not equal to the square root of 4 minus the square root of 6x or something like that. Nothing distributes over addition. Not squares, not square roots, not anything. Just multiplication. Right? 3 times a plus b is 3a plus 3b. That's it. That's it. That's the only thing you can distribute over addition is multiplication or division. A plus b over 3 is a over 3 plus b over 3. Squares, square roots, logs, sines, cosines, I don't care what it is, what function. It doesn't distribute over addition or subtraction. So if I'm going to square this, this is equal to 4 minus 6x squared minus this product times 2. 4x, 4 minus 6x plus 4x squared equals 0. We did not eliminate the square root. We didn't eliminate the square root, okay? The reason why that didn't work, okay, is because I don't have just a square root on the left. So I shouldn't square it yet. I have to just have a square root on the left or on the right or on both. Right? So I moved the 2x over here. So now I have square root 4 minus 6x equals 2x. Now I can square both sides and, oh, square root's gone. Great. Okay, but here you can't. It doesn't work like that. Right? A plus b squared is a squared plus 2ab plus b squared. So you gotta apply that thing there. Okay, so there's that. There's one more thing left to cover in this section. We'll do that not tomorrow, but on Monday. Okay, so I'll have an assignment for this section, and open up the web assignment for this. We're gonna spend another day and a half probably on this. Another day. Okay, so I'll have that due next week, and I'll send that with the email after class. All right, everybody have a great weekend.